So if you have basically these three masses, M1, M2, M3, the pulleys are essentially massless, the strings are essentially massless, they are very, very light. So you have three masses, you know the values of M1, M2, M3, and you basically have to just figure out the expressions of M1, M2, M3. Of course, you can then figure out the other things. So what are the tensions, what's the expression of pulley, and so on and so forth. Okay. Right. So let's then start solving this. You have to find out the expression in terms of M1, M2, M3, and G. Okay, so the first thing that you do always is that, okay, I have to find out the expression of M1, M2, M3. So what do? You draw the free body diagrams, at least of the objects which you are interested in. Okay, so you first of all draw a free body diagram for M1, M1G. That's the weight of M1. There's T1. Again, you cannot assume beforehand that the tensions are equal. They actually are not in this case. The tension force for M3 is not equal to the tension force for M1, as you will see. Okay, so do not assume things about the tension force to begin with. Okay, let's just same होगा उसके. But again, हमेशा नहीं. जब अब इसलिए मैं बार-बार point out जब बाद में अब rotations, when you go and study rotations, the tension won't be the same. एक महीने बाद आ जाएगी. Okay, it's not you're not pushing it 1 year down the line. Okay, and but it's important to recognize क्योंकि बाद में वरना आप फिर बहुत confused हो जाओगे. सर अब क्यों change हो गई है? Okay, why is it different now? Okay, so it's very clear, very important to make it clear right now कि क्यों same है. Because then it become clear later on very quickly कि अब क्यों change हो गई है. Okay, so anyway, for M2 is basically the same thing, M2G, except that the weight is different, of course, and this is T2. For M3 you have here you go. Okay, again there's a very, very common confusion over here which I keep on seeing is, you try to think more beyond your means. Okay, think jitna chalgoza hai utna hi socho. Okay, but anyway, besides that, there's this inclination to think that M2 has an influence on M1 and therefore M2 should be exerting a force on M1. Yes, it is true. I'm not going to dispute that statement that M2 has an effect on M1. But just because something has an effect on something else doesn't mean that it's exerting a force on that something else. M2 exerts an influence on M1 via the string. M2 exerts a force on the string and then the string exerts a force on M1. If you didn't have M2, what would happen to M1? M1 would just fall straight down with excitation G. It's only via the presence of M2 that the excitation of M1 will be different than G in general. So M2 is of course exerting an influence on the M1. That does not imply that it's exerting a force on M1. You can always have a third party. Okay, if you have a person in between, here's this, a person. There's another person over here, the left person, जो कि इसको खींच रहा है उस तरफ. This is person A, this is person B, then there's another person over here to the right, person C. ये उसको उस तरफ खींच रहा है. Of course, if person A is much stronger than person C, what do you think happens? Both B and C go to the left. C obviously feels the influence of A. But A never touched C. A only pulled B. You can have an interaction between two objects via a third party. Okay. This was an important insight, by the way. आपको एक trivial सी observation लग रही है. This is a Nobel Prize winning insight back in the 1950s. There was this mystery कि superconductivity क्यों होती है. Electrons, why are electrons in some materials able to travel through materials without facing any electrical resistance? And then people figured out in the early 1950s that electrons जो हैं, if there's kind of an attractive force between two electrons, then it implies, they did the calculation that it implies that electrons then can kind of group together, bunch together and move as a collective group such that collective वो जो हजूम होगा electrons का वो आसानी से disturb नहीं हो सकेगा. That's why resistance doesn't take place. Then the big mystery, of course, was that electrons के दरमियान attractive force, two electrons will always repel each other. But then somebody worked out that if both electrons are effectively interacting with the crystal lattice जो आपका लैटिस जो sea of positive ions है, याद आया वो sea of free electrons or positive ions. If all the electrons are interacting with the positive ions, basically this is the ion, this is one electron, this is one electron. The net influence can be कि सच के दोनों एक दूसरे की तरफ अट्रैक्ट हो जाएं A और C. ये बड़ी तेजी से खींचे इसे B को और ये बड़ी कमजोर तरीके से खींचे तो क्या होगा? C जो है लुढ़कता हुआ जाएगा A की तरफ. You can have an attractive force indirectly via the interaction of the electrons with the positive ions. And then you actually did the calculation and they show, देखो we experimentally produce values and we आ रही हैं, assuming that this is how the electrons interact with each other. Yeah. So anyway, okay. Right? Okay, anyway, this is what the guy was thinking about while he was flying to Sweden. Okay. उसको already Nobel Prize मिल चुका था. This was the guy who was the only person to win 2 Nobel Prizes in physics. कौन था जिसने 2 Nobel Prize जीते थे फिजिक्स में? नहीं मैं नहीं, अस्तगफुरुल्लाह नहीं. उसका पहला, अच्छा आप तो कंप्यूटर साइंस स्टूडेंट हो, उसका पहला नोबेल प्राइज किस पे था? फॉर इन्वेंटिंग द ट्रांजिस्टर, जो आपका लिटरली आपका बैकबोन है सारे कंप्यूटर साइंस का. आई मीन प्रैक्टिकली स्पीकिंग. उसने दूसरा नोबेल प्राइज सुपर कंडक्टिविटी भी जीता था. ओके, फॉर एनीवे. ओके, जॉन बार्डीन, दैट वाज हिज नेम. ओके, उसकी बायोग्राफी पढ़ लेना कभी. एनीवे, सो बैक टू दिस. ओके, सो just don't confuse. Okay, you बार-बार में देखो, ये आपकी जो सारी ट्रक फोर्स और मैन फोर्स और एलिवेटर फोर्स, उनकी यही द रूट कॉज इज दिस कंफ्यूजन कि भाई एलिवेटर में एक बॉल फेंका तो वो फील तो करेगा ना इन्फ्लुएंस का एलिवेटर एक्सेलरेट कर रहा है. नहीं भाई, जब वो तो हवा में है, वो उसको क्या पता एलिवेटर एक्सेलरेट कर रहा है नहीं कर रहा. द बॉल इज नॉट इवन टचिंग द एलिवेटर. Of course, indirectly you do end up feeling the influence of the accelerating elevator, क्योंकि वो ज़्यादा जल्दी से फ्लोर ऑफ एलिवेटर को हिट कर देगा. But that's due to the motion of the elevator, not because of some force was exerted between the ball and the elevator. Okay? Anyway, so then once you have drawn these free body diagrams, this is basically your pseudocode. Now you have to, write down the code. You first set up your unit vector. ये आपकी लैंग्वेज है, वेक्टर्स की लैंग्वेज में आप जाओ. नाउ यू राइट डाउन द एक्चुअल कोड. ओके, विच इज बेसिकली के T1 minus M1G equals M1A1. डोंट वरी अबाउट कि भाई M1 ऊपर जा रहा है या नीचे जा रहा है. लेट न्यूटन टेल यू दैट. वंस यू सॉल्व द लीनियर इक्वेशंस, अगर वो A1 का पॉजिटिव साइन के साथ नंबर आ जाता है, दैट मींस M1 इज गोइंग एक्सलेटिंग अपवर्ड्स, because that's the way that you set up your axis. That's the direction of your unit vector. This is actually shorthand for, just to be precise, this equation is shorthand for this. T1 EY minus M1G EY equals M1 A1 EY. This is actually what this diagram stands for. But then of course these two vectors are only equal if the components are equal. So that's why you just directly write down this. लेकिन A1 being negative, you can see that with this original equation means कि ये downward acceleration है. The minus sign goes with the unit vector. तो सर F is equal to ma, हमने तो वेक्टर्स देखे ही नहीं. अब ये तो आप यही लिखते रहते हैं बैठ के. वेल की जब साइंस डालूंगी एसेंशियल वेक्टर से ही आ रही हैं. Okay, why is my M1G coming with a negative sign? Because that's the direction of my unit vector. If I had chosen the downward direction as my unit vector, फिर मैं लिखता M1G minus T1 is equal to M1A1, which is perfectly fine. फिर अगर M1 नीचे की तरफ जा रहा हो, then A1 would then be positive. अगर ऊपर की तरफ जा रहा होता, then A1 would be negative. Perfectly fine. आप उल्टे हो गए. Physics allows that without much effort. Okay. Okay, so you have that. Anyway, so you do the same thing with M2, and you get basically T2 minus M2G is equal to M2A2. And let me just write it over here. T1 minus M1G is equal to M1A1. Do the same thing for T3, M3. So you have basically three equations that follow from Newton's second law. for M1, M2, M3. Of course, you can apply it in the horizontal direction as well, except that there's no horizontal force, so you end up, and there's no horizontal acceleration, so you end up showing the profound effect that 0 equals 0. Okay, Fx is equal to max. Okay, so anyway. So you have now, once you have written down the equations that follow from your free body diagrams with the unit vector that you have chosen, you stare at them, as in you count. Okay, if you cannot do this, then you know, मेरे पास इलाज नहीं है, go to an eye doctor. Okay, how many equations are there? Okay, 3. Okay, या 3 या जो भी आपने language इस्तेमाल करनी है. Okay, how many unknowns do you have? Remember, you have to write down everything in terms of M1, M2, M3, and G. So don't count M1 as an unknown, don't count M2 as an unknown, don't count M3 as an unknown, don't count small g as an unknown. T1, T2, T3, A1, A2, A3. You have 6 unknowns. How many equations do you have? 3. You cannot solve it. You can be the world's smartest mathematician. Well, if you were the smartest mathematician, you wouldn't be trying to do this in the first place. But if you couldn't be the world's smartest mathematician, you still cannot find a unique solution to these equations. That's mathematically impossible. या आप अपने अगले सेमेस्टर लीनियर अलजेब्रा के कोर्स में you can prove it that if you have the number of linear equations is more than the number of unknowns, your solution cannot be unique. Okay, so you need 3 more equations to get a unique solution. You only have a unique solution if the number of equations equals the number of unknowns. So you need 3 more equations. Where do those equations come from? Well, typically in these problems, you know, question के text में written होगा. Assume that the pulleys are massless, assume that the strings are massless, assume that the string is inextensible. Okay, so now one by one I'll be using these 3. Okay, सबसे पहले we use the fact that the string is massless. How does that help us? That essentially helps us is relating the tensions to each other, along with the fact that the pulley is massless. Okay. So let's focus on pulley B. This is M1 here, M2. No, M1, M2 and M3 are arbitrary values. Okay. Acha. Now to begin with, and this is always the same tricks that you use, okay. You focus on this segment of the string, this yellow segment of the string. अगर पूरी string massless है या उसका बहुत छोटा mass है, what's the mass of this segment of the string? That is essentially also effectively massless. What are the forces acting on this yellow segment? Yes, I know कि ये free body diagram मैं नहीं बना रहा technically speaking, क्योंकि मैं अलग से yellow segment नहीं बनाई, but I'm being a lazy bum, okay, so forgive me, okay. तो ये yellow segment पे कौन सी force लग रही है? There's T1 downwards. Where is this force come from? That's the force that the block is exerting on this segment of the string. Is the reaction force to that, so to speak, is exactly what you drew before. जो आपने T1 minus M1G लिखा है. Okay. And then of course this cannot be, this follows from Newton's third law, or you know, it doesn't even follow. I usually avoid saying a force follows from Newton's third law, because of course forces always follow from interactions. Newton's third law is just there as a check. कि भाई ये चीज़ अगर उसके साथ interact कर रही है, then of course this thing is also automatically interacting with other thing. Forces always use interaction. Forces third law से नहीं आती. Third law is there just as a check कि वो वाली force miss तो नहीं कर ली. Okay, so because the string is pulling this M1 upwards, automatically the block is pulling the string downwards. That's what this force is. Okay. Okay. But this cannot be the only force on the string, because the string is massless. If this was the only force on the string would be zooming downwards. That doesn't happen. What's responsible for preventing this string from zooming downwards? ये ऊपर वाला जो string का part है. जो string के इधर atoms है वो भी तो उसको खींच के रखे होंगे यार, string ताकि हम बरकरार रहें, हम टूट ना जाएं, कट ना जाए दरमियान में string में. The string doesn't snap. So there's a force upward of the same magnitude. Why? Because you want the net force on this massless string to be 0. If you have A is equal to F over M and the mass of your object is very, very small, and this is a finite number, the only way you can get a finite number over here is if F is also infinitesimal. The ratio of 2 infinitesimal numbers can give you something finite. That's exactly what happens in a derivative. But if F was finite, F remember is the net force, F was finite and M was infinitesimal, this thing is infinity for sure. But this thing is not infinity over here, physics. Okay, your block is not going to zoom up. Okay, another way to see that is suppose कि acceleration हमारी 2 है. This equals f over a very very small number. What is f then? A very very small number. F is the net force. So इस पे net force should be a very very small number. So अगर ये T1 है, then effectively that force is also T1. It's as simple as that. It's just multiplying a normal number with a small number. That's all it is. You multiply a normal number 2, 1, 5 with a very small number. What do you get? A very small number. So the net force should be a very small number. So that means that the total force, since it's a very small number, the forces should balance out to a very very good approximation. Okay, when we say massless, of course we mean that this mass of the string is much smaller than the other masses. Okay. Right. So you have T1 over here. For by exactly the same argument, I can look at the right segment of the string. Either force T2 होगी, then of course this follows kind of from Newton's third law. आपने उधर बनाई कि भाई M2 को ऊपर की तरफ खींच रही है string with force T2. Then the block pulls down on the string with T2. And notice कि देखो ये वाली segment खिंचाव में, it's being pulled on both ends. आपकी जब भी string कोई tension में होगी, it's always be pulled from both ends. It won't be pushed, of course. Then the string immediately buckles. Okay, that's another very good check to see कि भाई strings पे आपने forces सही बनाई या नहीं बनाई. It's very easy to get confused about the direction of the tension force. Just check it, okay? क्योंकि string खिंचाव में है या नहीं है. Okay, this force will also be T2. This force being equal to this force follows from the massless string. This force being equal to this force follows from the massless string. Okay. अब pulley को देखो. Look at the pulley and this segment of the string, this green segment of the string, this upper half semicircular segment of the string. Let's look at that. अब इस पे क्या forces लग रही हैं? There's of course the weight of the pulley, but that's negligible because again we are assuming a massless pulley. What other forces are there? नीचे की तरफ T1, नीचे की तरफ T2. हाँ, pulley भी massless है. Right? This is essentially the reaction force to T1. This is the reaction force to T2. ये force किधर से आई है? ये वाली जो segment है green वाली, इसने इसको ऊपर की तरफ खींचा. Then correspondingly ये वाली segment, this segment pulls the green segment down with force. Yeah. So that's why kind of the tension is being equal throughout. Okay. अब ऊपर की तरफ भी, अब of course ये वाली सिर्फ दोनों forces नहीं हो सकती on the pulley, because otherwise the pulley would fall infinitely fast. Because the pulley is also massless, so the net force on the pulley needs to be 0. So this should be T1 plus T2. Yeah, of course this is nothing other than the tension in the string over here. So the tension in this string over here is the sum of the tensions over here. Acha. We can also find out the relationship between T1 and T2 from here. If you notice कि ये pulley एक disc है essentially. It's something that can spin. Of course it does spin. So for example, M1 अगर ऊपर जा रहा है, M2 नीचे जा रहा है, this pulley will spin clockwise. It rotates. Now something rotates depending on, roughly speaking, we'll make it more precise when it comes to rotations. The lighter something is, the less mass it has, the easier it is to rotate something. If you make a disc out of aluminium, that is much easier to rotate compared to a disc made out of lead. Okay, so if your pulley is massless, that means that it's very very easy to rotate it. Okay, why does something rotate? Because of the presence of a torque. The pulley rotates about this axle over here. What's the torque due to about the axle? ये pulley force जा रही है, this produces zero torque. इतना तो आपको हाई स्कूल से याद ही होगा. When the line of action of a force passes through the point about which the torque is being calculated, the torque is zero. Okay, the torque due to T1 is anti-clockwise. The torque due to T2 is clockwise, opposite. The torque due to T1 is T1 times capital R, where R is the radius of the pulley. The torque due to T2 is T2 times R. You want the total torque now to be 0. otherwise this pulley will spin infinitely fast क्योंकि ये massless है. You want the total rotational tendency to also be zero क्योंकि essentially what comes out is basically that alpha is proportional to the torque, angular acceleration is proportional to the torque divided by the mass. ये आप करोगे रोटेशंस में, ओके, बट फिजिकली इट सीम्स ऑब्वियस कि इस केस में आप जो रोटेशंस की बात कर रहे हो, व्हाट कॉजेज रोटेशनल मोशन टू चेंज? टॉर्क. Previously, what you were talking about A is equal to F over M. This was linear motion. What causes linear motion to change? Force. For a massless object, you want this tendency to be zero. Otherwise, आपका object zoom करके यहाँ से वहाँ चला जाएगा. What causes rotational motion to change? Torque. This is massless. You want finite rotations to take place. आप ये नहीं चाहते कि infinitely तेजी से पुली घूमने शुरू हो जाए. That doesn't happen. That can only happen अगर if it can only rotate with the finite speeds if the torque is very small as well. क्योंकि ये बहुत छोटा नंबर है m जो है. Exactly the same argument. हाँ.
आपने कहा था massless पुली है तो easily spin करेगा.
हाँ.
तो फिर torque zero क्यों है?
वरना infinitely fast spin करेगा ना.
वही तो होना चाहिए.
नहीं. It still is spinning with finite angular speeds. आपको जो टेंडेंसी है ना उसकी रोटेट करवाने की, वो भी बहुत छोटी होगी, फिर ही आपको फाइनाइट एंगुलर स्पीड मिलेगी. एग्जैक्टली जैसा फोर्स में हो रहा है. फॉर अ massless ऑब्जेक्ट इज वेरी इजी टू मूव द ऑब्जेक्ट. द ओनली वे यू विल गेट अ फाइनाइट एक्सेलरेशन इज व्हेन द टोटल फोर्स इज जीरो. सेम थिंग ओवर हियर. It's very easy to rotate a massless object. The only way you can get a finite rotation speeds is when the torque is very, very close to zero. With the equal and opposite torque है आपका clockwise anti-clockwise, फिर आपका you'll get finite rotation speeds. हाँ.
Sir, massless stationary है.
नहीं.
तो फिर pulley must spin for one of the masses.
Yeah, इसलिए मैं कह रहा हूँ. But it needs to spin at finite speeds. अगर ये torque non-zero हो जाएगा, it starts to spin infinitely fast. ये मसला है ना आपको. Okay, you need finite values of the angular acceleration.
But how does it spin अगर torque zero है?
नहीं, torque क्योंकि उसका mass भी zero है ना. Exactly जिस तरह इधर था. How is the pulley able to accelerate vertically if the total force on the pulley is zero? Well, because the mass is also zero. Essentially जैसा मैं show किया था, 2 is equal to F over 0.0001. एक्सेलेरेशन अभी 2 है, लेकिन टोटल फोर्स क्या है? बहुत छोटी. Okay? Because that's why we essentially say that 0 by 0 is indeterminate. That usually, physically speaking, that is a sign कि उसकी वैल्यू किसी और तरीके से निकालें. आपकी एक्सेलरेशन इधर से आप अगर f अगर 0 है और m भी 0 है, find out the acceleration of the pulley via some other means. For example, इस केस में मैं इस पुली की एक्सेलरेशन कैसे निकाल सकता हूँ? I cannot use the total force acting on the pulley because then I'll be ending up dividing 0 by 0. I can, however, find out the acceleration of the pulley indirectly. अगर मैं इसकी एक्सेलरेशन निकालूं, क्योंकि it turns out very soon I'll be showing you कि जितना ये ऊपर जाएगा उतनी पुली नीचे जा रही है. The acceleration of the pulley in magnitude will be equal to the acceleration of m3. तो इसलिए आप वो indeterminate कहते हो कि इस तरीके से नहीं डिटरमिन हो सकती. Use some other way if possible. ओके, ठीक है. तो दैट्स मेंट टू रीइंफोर्स के भाई सफ़ेद झंडा ना लहराने शुरू कर दो. आप लोग तो सफ़ेद झंडा से लहरा रहे होते, बस सर बहुत हो गया, वी गिव अप. ओके, एनीवे, सो देन T1 equals T2 because otherwise the total torque won't be zero. And then just for simplicity of notation, I'll say T1, I'll just write it as T. T2 then of course is also T, and T3 is 2T. Why? Because then exactly the same argument I can use for this pulley. अगर इधर टेंशन 2T है, तो फिर इधर भी टेंशन 2T होगी. Otherwise this pulley will start to spin infinitely fast. Of course अगर मैं आपसे कहूँ कि हुक पे कितनी फोर्स है, वो कितनी होगी? 4T. Okay, that's how it goes step by step. Okay, ठीक है. क्योंकि इस पुली D के ऊपर there will be two downward forces, 2T each, and then the force upward on pulley D will be 4T upwards. And then conversely, this is the force that the hook exerts on the pulley. then what's the force that the pulley exerts on the hook? 4T downwards. अगर वो जो जितने जिस कील के साथ आपने ये हुक को बांधा हुआ है, अगर वो 40 से ज्यादा 40 फोर्स नहीं सपोर्ट कर सकता, the whole thing will come crashing down. Okay, so going back over there, you are still not done by the way. ये T आपका बन गया, ये T बन गया, this becomes equal to 2 times capital T. हाँ.
लेकिन T3 तो वो M3 के ऊपर वाली टेंशन नहीं.
Yes, लेकिन वो इसके बराबर होगी because this pulley is massless by exactly the same argument. Okay. अब now you again stare at them. So you're back to step 4. Okay. You stare at them some more and you see yeah 3 equations हैं और 4 unknowns हैं आपको. You have A1, A2, A3 and capital T. Of course इधर ज़्यादातर लोग जो हैं वो सफ़ेद झंडे की बजाय रेड झंडा लहराना शुरू कर देते हैं और कहते हैं they express all answers in terms of capital T. The only issue with that is कि कहीं भी मैंने spring balance वगैरह नहीं लगाया हुआ, so I don't know the value of capital T. Okay, you are supposed to tell me capital T in terms of M1, M2 and M3. Okay, of course you solve them simultaneously right now. You'll find out A1 in terms of capital T and M1, M2 and M3. But that's not what I want. I want T in terms of M1, M2, M3. I want A1 in terms of M1, M2, M3. A2, M1, M2, M3 and so on and so forth. Okay. So need the fourth equation. वो किधर से आएगी? वो तो कर लिया. So we use the fact that the pulley is massless. We use the fact that the string is massless. एक चीज मैंने नहीं अभी इस्तेमाल की. The length does exactly. The length of the strings do not change. दो strings हैं आपकी इधर. एक ये वाली और एक ये वाली. The length of both strings does not change. तो पहले लेते हैं जी आपकी पुली D को. वो सिंपल है. वो मूव नहीं कर रही. That's why I'm taking. We always do the simpler case first, okay? क्योंकि उससे आप बहुत कुछ सीखते हो. Oh, क्यों कर रहे हो? Because you want to find out the relationship between the accelerations. और उसका लेंथ से ये ताल्लुक होता है because you can, if you experimentally figure out the accelerations, that is linked to the length of the string. वो भी मैं दिखाऊंगा, okay? But anyway, वो इसलिए लेंथ से linked है क्योंकि जितनी ये पुली ऊपर जाएगी, उतनी ये नीचे जाएगी. लेकिन ये आपने क्यों स्टेटमेंट मारी है? Because the length, you assume that the length of the string does not change. अगर ये स्प्रिंग कनेक्टेड होता यूं करके, फिर आप नहीं ये कह सकते कि जितना ये ऊपर जा रहा है उतना ये नीचे जाएगा. यूं ऑसिलेट करता यूं कर जा रहा होगा, राइट? यू वर ओनली एबल टू, एज इन जितनी स्ट्रिंग इधर से गायब हुई है कंजर्वेशन ऑफ मैस, उतनी इधर आ गई होगी. ओके सो that's why you say, that's why then you are able to say जितना ये ऊपर गया उतना ये नीचे गया. AKA then you can say कि if the whole thing, I mean then it's obvious कि जितनी इसकी upward acceleration होगी उतनी इसकी downward acceleration होगी. Okay. नहीं, एक दफा हम center of mass कर लें फिर आप कर सकते हैं आराम से. I mean right now you cannot do it because you don't have the tools to do it right now. Okay, पर वो इतना मुश्किल नहीं है, वो आसान ही है. Okay, anyway. नहीं अभी आपके पास टूल्स नहीं है ना. अभी आप वो स्प्रिंग वाला प्रॉब्लम इस तरह इस कॉन्टेक्स्ट में करने की कोशिश करो. दैट्स लाइक शूटिंग अ राइनो विद कुछ भी फोर्क फॉर एग्जांपल. या फोर्क वुड बी अ गुड थिंग. ओके, अभी आपके पास टूल्स नहीं है वो. एनीवे, यू नीड अ बजूका, यू विल गेट द बजूका. ओके, सो पुली डी को देखते हैं. ओके, सो पुली डी, देयर इज अनदर पुली ओवर हियर. ठीक है, and then there's M3 over here, right? अब ये pulley of course move कर रही है, and there's some acceleration of the pulley. This M3 is also moving vertically. There's some acceleration for M3. How do I experimentally measure these accelerations? Essentially आप किसी reference point से height measure करोगे इसकी. आप ये कहोगे YP. If I can figure out how does YP change as a function of time, I know the acceleration of the pulley. I just need to look at the rate of change of the rate of change of YP. That gives me the acceleration of the pulley. Same thing for M3. अब एक और कमेंट, सर आपको कैसे पता टॉप ऑफ बॉक्स से लेनी है? that I'm just doing to make my life simple. As the box moves, the shape of the box does not change. That's a reasonable assumption to make. तो ये लाइन अगर मैं यहाँ से मेजर करूँ, श्योर ठीक है कर सकते हो, but then you can also relate कि ये कैसे डिस्टेंस चेंज होता है, क्योंकि ये कैसे डिस्टेंस चेंज होता है. मैं इधर से इसलिए मेजर करना प्रेफर करता हूँ because then writing on the length of the string mathematically becomes much simpler. Length string जो है यहाँ से शुरू हो रही है. Then you know, as you'll see, it leads to some mathematical simplifications, but that's not necessary. आप यहाँ से भी measure कर सकते, यहाँ तक भी measure कर सकते हैं. Okay. Okay. Then the thing is कि ये पुली की height जो है ये change नहीं हो रही. Let's call that capital Y. अभी तक कोई आपको कोई length of string तो आई नहीं. But now I said I'll be drawing a link between the length of the strings and the accelerations of the masses. और एक्सेशन ऑफ द पुलीज. तो इधर अब yp का डबल डेरिवेटिव जो है दैट इज द एक्सेशन ऑफ द पुली, y3 का डबल डेरिवेटिव दैट इज द एक्सेशन ऑफ m3. आई जस्ट नीड टू राइट डाउन द लेंथ ऑफ स्ट्रिंग इन टर्म्स ऑफ yp एंड y3 एंड मे बी कैपिटल Y एज वेल. सो लेट्स डू दैट. ये आपकी स्ट्रिंग जो है ये यूं करके जा रही है. आई कैन डिवाइड द स्ट्रिंग इनटू 3 पार्ट्स. एक ये येलो सेगमेंट, एक आपकी ग्रीन सेगमेंट और एक आपकी well I'm out of markers, एक आपकी white segment. Okay, so write down the length of the string. Let's call it capital L. Capital L equals the length of the yellow segment, which is equal to capital Y minus yp plus the semicircular segment, which is मेरा कन्वेंशन खराब हो गया. प्लस क्या नहीं, वो पाई आर हो गया. प्लस ये कैपिटल Y माइनस y3. दिस इज द मैथमेटिकल representation of the link between the length of the string and the positions of the different objects. अब तक आपने सिर्फ एक सिंपल सी मैथमेटिकल जो कहते हैं ना टोटोलॉजी लिखी है essentially. Now you essentially have to use the fact that capital L does not change with time. What does that mean? That dL by dt equals 0, and the second derivative of L with respect to t is also 0. कि L हमेशा अगर एक ही वैल्यू रहती है, एक हॉरिजॉन्टल फ्लैट लाइन है उसका डबल डेरिवेटिव भी 0 होता है, ट्रिपल डेरिवेटिव एंड सो ऑन. तो ये अगर दो दफा मैं डिफरेंशिएट करूं, I look at how does capital L change with respect to time twice, I get 0 on the left hand side. कैपिटल Y का डबल डेरिवेटिव क्या आएगा? 0, बिकॉज दिस पुली इज फिक्स्ड. इसका क्या डबल डेरिवेटिव आएगा? द एक्सेशन ऑफ द पुली, लेट्स कॉल इट कैपिटल A. द एक्सेशन ऑफ द मूवेबल पुली एज इन एक्सेशन ऑफ पुली B. पाई R का डेरिवेटिव क्या आएगा? 0, अगेन अज्यूमिंग दैट द शेप ऑफ द पुली डज नॉट चेंज. प्लस कैपिटल Y का डेरिवेटिव माइनस A3. So you can see straight away that A3 equals minus A, या A is equal to minus A3. अगर पुली ऊपर जाएगी जितनी एक्सेशन के साथ उतना ही M3 नीचे जाएगा. इसका डबल डेरिवेटिव क्या है? इसका डबल डेरिवेटिव, इसका डबल डेरिवेटिव, एक्सेशन ऑफ द पुली. कैपिटल Y ये वाली पुली की लोकेशन फिक्स्ड है. कैपिटल Y is the height of this pulley which cannot move. yp ये मूवेबल पुली, जो पुली B है उसकी वर्टिकल पोजीशन है, उसका डबल डेरिवेटिव आपको क्या बताएगा? एक्सेलेरेशन ऑफ दिस पुली. बाय डेफिनेशन ये तो डेफिनेशन है एक्सेलेरेशन की. ओके, और फिर इसका डेरिवेटिव 0 होगा. कैपिटल Y ये फिक्स्ड पुली की हाइट है, उसका डबल डेरिवेटिव 0. ये y3 का डबल डेरिवेटिव बाय डेफिनेशन इज a3. बाय डेफिनेशन एक्सेलेरेशन रिमेंबर इज द डबल डेरिवेटिव ऑफ द पोजीशन. ठीक है क्या? क्योंकि आपने लिंक करना है पोजीशंस को एक्सेलरेशंस के साथ, इसलिए. ओके, राइट. सो देन यू कैन से स्ट्रेट अवे हैव दिस इक्वेशन दैट कैपिटल A इक्वल्स माइनस A3. ये तो आया यूजिंग द फैक्ट दैट ये वाली स्ट्रिंग की लेंथ चेंज नहीं होती. नाउ आई यूज द फैक्ट कि ये वाली स्ट्रिंग की लेंथ नहीं चेंज होती. बेसिकली द डेरिवेशन इज एग्जैक्टली द सेम एक्सेप्ट के इधर मैं हटा के मैंने बनाना है एक डब्बा बना देना है. और इधर आ जाएगा m2 और ये बन जाएगा y2 और ये बन जाएगा yp रह जाएगा, ये सॉरी ये yp नहीं, ये मेरा बन जाएगा yp, because now of course over here you have the movable pulley. Okay, इसको हम L prime कह देते हैं because there is nothing that says कि ये length of string is the same as this length of the string. It doesn't really matter क्योंकि derivative दोनों केसेस में 0 ही होगा. But anyway, there is nothing that says that the two lengths are the same. So L prime, the length of this string that connects M1 to M2 now, is equal to capital Y, Yp minus, ये Y1 अब कहो इसे, Yp minus Y1 plus pi r, अगर आप चाहते हो इधर भी प्राइम डाल दो, there is nothing that says that the radius of the two pulleys is the same, doesn't matter, plus इसका क्या है, Yp minus is the same game that you play in every single pulley problem. So that's the good news for you. Pulley problems are very, algorithmic in nature. इसी किस्म का काम तकरीबन आप हर pulley problem में कर रहे होते हैं. First, apply Newton's second law. You'll find less equations, more unknowns. Use the fact that the pulleys are massless and the strings are massless to find out the relationship between the tensions. Then use the fact that the string's length doesn't change, इसी तरह ही, to find out the relationship between the accelerations, solve simultaneously. Done. Okay? तो ये बड़े हलवा क्वेश्चन होते हैं असल में. पहली दफ़ा देखो आपको खौफ आ रहा होता है, ट्रस्ट मी, एक दो दफ़ा 2-3 और सॉल्व करोगे आपको कहोगे ये तो बिल्कुल ही हलवा है. ओके, बिकॉज देयर इज अ वेरी, आपके पास एक रोज किस्म का आपको जर्नी सेट है आपकी कि आपने करना क्या है, आपको जो क्या करना है उसके बारे में सोचना ही नहीं पड़ता. ये आपके लिटरली ए लेवल वाले सवाल हैं, काइंड ऑफ क्वेश्चन को एमसीक्यू को देख के आंसर पता होता है. ओके, क्या आंसर है. ओके, सो इट्स काइंड ऑफ लाइक दैट. ओके, ओके, so now you differentiate both sides twice. L prime का डेरिवेटिव क्या होगा with respect to time? Twice 0. Yp का ये मूवेबल पुली है, कैपिटल A, इसका डेरिवेटिव A1, इसका डेरिवेटिव 0, इसका डेरिवेटिव कैपिटल A अगेन, इसका डेरिवेटिव minus A2. So now you have that A1 plus A2 equals 2 times capital A. So if the pulley is accelerating, the masses on the motion of the masses on both sides are of course also affected by the motion of the pulley. That's what this thing is telling you. B pulley और D pulley की एक्सेशन सेम नहीं है, of course. तो मैंने कब कहा सेम? D की तो एक्सेशन है ही 0. D तो वैसे ही फिक्स्ड है. Okay? And then you have ये, और फिर दूसरी साइड पे हमें ये भी थी. So then I can write down that A1 plus A2 equals minus 2A3. लो जी, आ गई आखिरकार. And then you have 4 equations, 4 unknowns solved simultaneously. 3, in case you have forgotten. आप बोल रहे थे कि किधर रह गए ऐसी, वो 3 equations उधर भी हैं from Newton's second law. This is the 4th one. Solve all 4 simultaneously. Okay? They are quite simple equation. I mean, बिल्कुल सिंपल सी लीनियर इक्वेशंस है, कोई स्केयर भी नहीं आपको नजर आ रहा, तो इतना साइमल्टेनियसली सॉल्व करना कोई इतना मुश्किल नहीं है. ओके, दैट आई लीव फॉर यू टू डू. और बाकी क्वेश्चंस टिपिकली यही होंगे. इन क्वेश्चन का मसला ये होता है कि जब तक पहला पार्ट नहीं हुआ तो कुछ भी नहीं हुआ. You have to find out the extension of M3. You essentially are finding A3 in part A. एक दफा वो हो गया तो you kind of know कि बाकी सब तो हलवा हो गए. पार्ट B में क्या पूछ रहा है वो? कैपिटल A. Extension of pulley B is capital A. Capital A is, once you have done part A, you just need to attach a minus sign. Part C is A1, part D is A2, part E क्या है? T, capital T in terms of M1, M2, M3. Part F क्या है? 2T. और part E क्या है? Well, you plug it in और फिर देखो. Do part G और क्या है?
जो केस की जो वैल्यू है वो M1, M2, M3 की टर्म्स में आएगी ऐसे?
M1, M2, M3 और G की टर्म्स में आएंगे. सारों के आपके सारे आंसर्स A से लेके G तक all of them will be in terms of m1, m2, m3. Apart from g, of course, क्योंकि उधर m1 equal to m2 का आ रहा है, so you probably only see m1 and मतलब a variable आपको नहीं नजर आएगा because you are doing the special case where m1 equals m2. Okay? नहीं, a1 और a2 equal नहीं होंगे, किसने कहा equal? नहीं, क्योंकि पुली भी एक्सरेज कर रही है ऊपर की तरफ, तो एक किस्म का आपको धागा करो, कंजर्वेशन ऑफ धागा, आपकी लेफ्ट ब्रांच से तो धागा गया है उतना का उतना नहीं वापस नीचे दूसरी साइड पे आना, क्योंकि पुली एज अ होल भी तो ऊपर चली गई है, इसलिए आपका a1 प्लस a2 0 नहीं है। अब
वो पुली और ये वो जो धागा है और ये वाला धागा
इंडिपेंडेंट है, इसलिए मैं कह रहा हूँ जो पुली a3 और पुली की एक्सेशन के दरमियान स्ट्रेट फॉरवर्ड सा लिंक है, जितना ही पुली ऊपर गई है उतना ही ये नीचे गया, लेकिन इन दोनों के एक्सेशन का लिंक इज मोर कॉम्प्लिकेटेड, क्योंकि पुली भी ऊपर गई है, जितना धागा इधर से गायब होगा उतना ही धागा इतना नहीं आना कि पुली जब ऊपर गई है उसने भी कुछ धागा खा लिया है, सो टू स्पीक। ओके